Good morning, class. We are Team 8 and our topic is Geographic Information Systems. What is Geographic Information System? A Geographic Information System is a computer system for capturing, storing, checking, and displaying data-related positions on Earth's surface. Geographic Information System allows us to view, understand, question, interpret, and visualize our world in ways that reveal relationships, patterns, and trends in the form of maps, globes, reports, and charts. In a geographic information system, you connect data with geography. You understand what belongs where because you don't fully understand your data until you see how it relates to other things. It is really hard to visualize the location of latitudes and longitude coordinates from a spreadsheet. But when you add these positions on a map, it's like magic to the reader. Everyone knows that map makes geographic information easier to understand. These are the steps in geographic information system: to create geographic data, to manage it, to analyze it, and to display it on a map. And these are also the primary functions of a geographic information system. GIS requires both hardware and software. Hardware ranges from potential servers to mobile phones. GIS analysts often need dual monitors, boatloads of storage, and crisp geographic processing cards. The GIS software options out there seem endless. Some examples are ArcGIS, QGIS, GRASS GIS, SuperGIS, Saga GIS, and Jump GIS. GIS can use any information that includes location. The location can be expressed in many different ways, such as latitudes and longitudes, address, or zip code. Many different types of information can be compared and contrasted using GIS. The system can include data about people, such as population, income, or education level. It can include information about the land, such as location of the streams, different kinds of vegetation, different kinds of soil, etc. It can include information about the sites of factories, farms, and schools, or storm, drains, roads, and electric power lines. Putting information into GIS is called data capture. Data that are already in digital form, such as images taken by satellites and most tables, can simply be uploaded into GIS. Maps must be scanned or converted into digital information. Let's talk about managing geodata now. SQL and enterprise geodatabases. The enterprise geodatabases can be used with SQL to access existing datasets and their properties and edit datasets. You can use SQL select statement to obtain the properties of existing datasets in the geodatabases. You can use SQL select statement to return data from the existing datasets in the geodatabases. You can use native SQL of your database management system to edit the simple, non-spatial attribute data in the geodatabase. You can also use the spatial SQL function installed with spatial types to alter simple spatial data using SQL. You can use the native SQL of your database management system to create and populate tables.
Spatial analysis is one of the most interesting and remarkable aspects of GIS. Using spatial analysis, you can combine information from many independent sources and derive a new set of information by applying a large, rich, and sophisticated set of spatial operators. There are a lot of ways to analyzing tools in every GIS software. These are the two examples of tools to analyze the geodata: the clip tool and the buffer tool. The clip tool can take a sample clip from the population and give the results in a way which is easy to study and analyze further. The buffer tool gives a buffer of the requested query made on the data. Geographic display techniques such as shading based on altitude in a GIS can make relationships among map elements visible, heightening one's ability to extract and analyze information. Here is an example of a geomap display. It is an integrated dataset of street data, building data, and vegetation data. We can clearly differentiate due to the 3D mapping ability of the software. These are the few applications of GIS. The first one is mapping densities. Sometimes it is more important to map concentrations or a quantity normalized by area or total number. Example below, we have mapped the population density of Manhattan. The total population counts normalized by the area in square miles of census tracts. Mapping quantities. People map quantities, such as where the most and least are, to find places that meet their criteria or to see the relationships between places. Example below is a map of symmetry locations in Wisconsin. The map shows symmetry locations as dots, and each county is color coded to show where the most and least are. Next is mapping changes. We can map the change in a specific geographic area to anticipate future conditions, decide on a course of action, or to evaluate the results of an action or policy. Example below, we see land use maps of Barnstable, Massachusetts, showing changes in residential developments from 1951 to 1999. The dark green shows forests, while bright yellow shows residential development. Applications like this can help inform community planning processes and policies. Finding what is nearby. We can find out what is happening within a set distance of a feature or event by mapping what is nearby using geoprocessing tools like buffer. Example below, we see the effects on features within specific radii of a simulated explosion. Use of buffering tools to generate set distances can aid in emergency response to disasters like these. Some of the advantages of GIS are as follows. Cost saving from greater efficiencies. GIS is widely used to optimize maintenance schedules and daily fleet movements. Typical implementations can result in a savings of 10 to 30% in operational expenses through reduction in fuel use and staff time, improved customer service, and more efficient scheduling. GIS is the go-to technology for better decisions about locations. Common examples include real estate site selection, route corridor selection, evacuation, planning, etc. Making correct decisions about location is critical to the success of an organization. Many organizations have a primary responsibility of maintaining authoritative records about the status and change of geography. GIS provides a strong framework for managing these types of records with full transaction supports and reporting tools. GIS is becoming essential to understanding what is happening and what will happen in the geographic space. Once we understand, we can prescribe action. This new approach to managing geographically, is transforming the way organizations operate. Thank you for your patient listening.